Okay, is there any comment or question about number 18? Just took a long time, right? Had to multiply each term by these three, so you multiplied 3, 6, 9 times, and then combine like terms. It's the magic of multiplying polynomials. Hopefully you've been able to get 6.2 completed in good order. And if you haven't yet, please do. If you have a grade that's not in the grade book, but you have completed it, let me know, because I will not know otherwise. Unfortunately, the software doesn't notify me when you finish an assignment past, the time it's in the grade book. So that would be great. I want you to get all the points that you deserve. Now, there are shortcuts to finding the coefficient described, but I would rather show you where it comes from, so then when you have this master that you can use a shortcut, then the shortcut's more meaningful. If I just show you the shortcut, it will last in your brain about that long. So I want to show you where it comes from, so then when you meet the monster, you'll be able to do it for yourself. Okay, so it's to the 6th power. So we are expanding a binomial. This is 6.3. And according to the binomial theorem, that every 6th power has the same set of coefficients. So that's where you pull out your Pastel's triangle. You know it's going to be in the row 6. And its second coefficient is 6. Then it goes 15, 20, 15, 6, and 1. So that isn't the coefficient itself. It's just the coefficient of the expansion of the binomial. We got to figure out, what's going to happen with that 2. That will change the actual coefficient. So be careful. That's not the done. That's not the done deal. We still have to write out our expanded binomial so we can find out the value of that into the 3rd term. Any questions about that? Okay. So now the expansion always starts with the first term of the binomial to the highest power there is. Now the reason I don't write a 1 in front is because 1 times anything is the thing. So that's why I just put into the 6. Then I always add, and I worry about the signs later. So I add the next coefficient of the Pascal's triangle times, if this was like a term other than n, I would put it in parentheses. If you want me to, I can do that. Like this would be hugged in parentheses. So this is hugged in parentheses to the 5th, and then my second term of the binomial shows up to the 1st. The exponents of the first term and the second term of the binomial should add up to 6. Remember what a binomial is? That's the 2-term guy. Remember what an expansion is? That's this yada, yada, yada. Remember what coefficients are? The numbers that are multiplied in front. And n to the 3rd hasn't showed up yet. So I'm going to have to go two more times because put my 15. This is n to the 4th. And then my 2 is squared. Guys see where I got the 15? My next, see that goes here, and then my next one, and I'm going to run out of sticky note. Should be okay, I think. I'll put a plus. It'll be a 20. Then my n is to the 3rd power. And then my 2 is cubed. Am I still on the screen? Nope. There we go. this is the coefficient I want. So my coefficient is what's being multiplied in front of n to the third. And that's 20 times 2 to the third times n to the third. And so 2 to the third is 8 times 20 is 160. Right page here. See, it is. Okay, could you do that without me? Could you write down the coefficients from the binomial, Pascal triangle? Could you march down the row until you hit the right power of n, and then simplify the numbers? Yeah? No problem? And who knows which one you're going to have as I think 7th power was the highest power I asked it to use. And so you might have a 7th, you might have a 3rd. Just don't know. Whatever the randomizer chooses. Now, 20 is a little tricky because the u is the second term. So be careful. We're not looking for, we're looking for that when the second term goes down to 2 or up to 2, whichever the case may be. So pay attention to what order this power is in. So write down my 4 coefficients, 1, 4, 6, 4, 1. That's an even, so I should have 1, 2, 3, 4, 5 terms. And I start writing my story. I'm going to write until I have u to b squared. So my first term is the first term of the binomial to the 4th power. And it's times the 1, so I don't have to write it. I'll go ahead and hug it. Because if you don't hug it, sometimes if they have like a number, a constant and a variable, you forget to take them both to the highest power. And then I'm going to bring the 4 down. Then the first term of the binomial goes to the 3rd power, and the second term shows up. Coefficient times first term goes down 1, and here we got our u squared. So now I can stop and do this math. 6 times 9 is 54. Number 20. Okay. B. So you got to know what you're doing. Otherwise, you will have no idea which one's the coefficient. You don't want that to rule your semester final, right? All right. Comments? See the patterns? See the patterns. Know the vocabulary? That's a big deal. Mathlish. Okay. 5th period. I sillily skipped 21 and 22 because when I folded this guy over, I just went to this direction. But what makes 21 and 22 unique? We're not looking for a power. We're looking for the term number. So that's a little different. Very different. It's a tricky one, for sure. And don't take shortcuts. Gotta understand where the math comes from before you can even think about doing shortcuts. Right. So we're looking for the 3rd term. So we'll literally count, 1, to 3 terms. It'll be this one is the one that I'll be looking for. So I got a 6th power. So my first 3 coefficients for n equals 6 is they're 1, 6, and 15. So now I play the game with the v. This is v to the 6th, and then I'll take 6, v, and I better hug it. There we go, v to the 5th times. Now remember the negative goes with the number here. Negative u. Am I still in the story? I am. That's to the 1st power. I got that one down. Now here's my next one. Plus 15 times v to the 4th, and it's a negative u squared. So that negative gets to be positive because the negative 1 times negative 1 is positive 1. So my final result is the 15 v to the 4th u squared. Would you guess that was the 3rd term? Tricky, huh? Right? 3rd term. Ah, what's a negative times a negative? That's the tricky. Yep, that's tricky as well. I don't know if they have that as a liar or not. No, they don't. Thankfully, they don't have a negative 15 to choose from. But that's why I want it in a hug. So I remember it is squared as well. So it is letter B. So that is how you calculate the term number. That's different than the power, isn't it? Any other questions? That was a good test of your ability to understand the binomial theorem. That's what created the coefficients and also how they know what the powers are. That's that. Okay, switch over here. The 22. So thankfully we only have to go 2. But it could have said 7, right? Or 8. Yeah. So does that help? I say the 2nd term is here. Does that help? Does that help your thinking? You got your 1st term, then your 2nd term. So all you need to do is have the, from your Pascal's triangle on row 7, you write your 1st coefficient and your 2nd coefficient. And the 2nd coefficient always matches a power on every row. So that helps you remember what it is. You don't have to memorize it, you just remember that. So I take my 1st term on my binomial to the 7th power, and then I take my coefficient, 7, 1st term of the binomial to the 6th power times my 2nd term. So this guy is to the 1st power, so the negative stays. So negative 7 y to the 6th x. I was concerned they were going to switch up x and y in the answers, but they didn't, so that's good. So B is your choice. So I'd have 2 of you find, when I give you the power of a variable, of a term, I have you find 2 of them when I give you the number of the term. And you can probably tell the shortcuts. You can tell the shortcuts. Now we're doing the whole thing. And sorry, that was from the last. That was from up there. So when I fold it back down again, you can see what that belongs to. So I'll just put in a new sticky note. Actually, for these, the 23 and 24, I needed to put 3 sticky notes across the whole thing. Because, yeah, it's the expansion. So after you write the pattern, then you have to simplify it. Let's see if I can get this one squeezed into 2 because it's only power of 5. This is my preference. I like to write the coefficients first so I can just draw from my paper instead of keeping looking back and forth at the triangle. So I'm going with 5. That means there's 6 terms and it goes 1 and a 5. Then I look up and it's a 10, a 10, a 5, and a 1. So odd powers, even numbers, these guys repeat, all sorts of different ways to remember what it is. You surprise yourself what you remember. Thankfully, the numbers won't be absolutely unmanageable because our second term is 1. So I take 1 to any power, I get 1 out. Yay, yay. So that makes it a little simpler. Okay, ready? We take our first term to the highest power, and I don't have to write the 1 in front. I take my second term of the expansion, use that second coefficient, and then the first term of the binomial to 1 less power, and then the second term shows up. You're going, well, I thought you didn't have to write that. Well, I want to show you, if it wasn't a 1, what you would do. Okay, I think I got a 10 next. Then I've got that 2n down a power and 1 up a power. Just taking the coefficient, always adding. I don't worry about the negatives till the end. Coefficient, let me see, I need another 10, don't I? And it looks like I'm going to need another sticky note. Okay, times 2n to the second power. That goes down 1, and then my 1 goes up to the third power. Squeeze it in here. Okay. I got to use my 10. Now I'm going back down again to a 5. 2n goes to the first power. 1 goes to the fourth power. I'm not on there, I am sorry. And then my last one, coefficient's 1, the second term is 1, and the power is 5 again. Well, they all ended with 1, so that's not going to help you. C has got, doesn't have, 2 to the 5th, so you got to do it all. And that takes more time. That's where there's only 2 of these. That's it. Back up. I'm going to do the math. 2 to the 5th is 32. 2 to the 4th is 16. Times 5 is 80. And then 1 is what it is, right? You guys with me? 16 times 5. Okay. Oh, look. This is 10 times 8. So that would be 80 as well. That's a coincidence. Just never know what numbers you're going to do. Always do the power first. Are you getting that drift? If you're paying attention, pay attention. I did not take 10 times 2 first. No, 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 no. And thankfully for multiple choice, you did the wrong thing. Just know what's right. 2 squared is 4 times 10 is 40. N squared. And then this is 10 N. And my last one is a 1. So 23, 32, 80, 80, 40, 10, and 1 is letter A. that guy down. Got it, everybody? Mr. Magnus, that was fun. Okay. Now we're going for our last expansion. Then we'll do a couple factors and then let you work on your lessons if you need to. So tomorrow, this practice test, it'll be different values. You know, tomorrow it'll be on CUDA while Mr. Borden is here. Okay? Alrighty. Sure, this one will take 3 for sure, because it's the 6th power. Right there. So I think of my coefficients. 1, 6, and it's got 7 of them. So 15, 20, doesn't repeat. 15, 6, and 1. Thankfully, we don't have to reinvent the wheel on that. Thanks to Pascal triangle. And if you didn't have a triangle, you could always put in the combination in your calculator, but I allow you the triangle, no problem. All right, so we take my first highest 1. So 2x to the 6th. Okay, second coefficient. First term down 1, second term shows up. Third coefficient, first term down 1, second term up 1. Moving on the first 15. All right, so I have a 20, first term, 2x. Am I doing x's? Yeah. We had n's the last time. I almost wrote an n. And that one goes down to a 3. And the 1 comes up to a 3. It is the mountaintop of the powers. Now they switch places. 15. I don't know if I'm going to get it in here or not. 2x. Uh-oh. There's 20? It's right in the middle. Yep. Okay. So I go 1, 6, 15, 20, and then I go back down to 15. And this is 1 to the 4th power. Yep, I'm going to have to go on the next line or something off my sticky note. Okay, this guy is the 6th, and 2x to the 1st. And 1 to the 5th, and I guess my last one's not bad to write. It's just plus 1 to the 6th power, so that's not bad. I missed that. It looked like a circle instead of a parentheses. There we go. And then the rest is arithmetic. If you're ready. Set. Okay. 2 to the 6th power. You guys know how to do that in the calculator, right? 64, x to the 6th. And that guy is 6 times 32. See if I did that one. Yes, 192. X to the 5th. Now the ones, thankfully, I don't have to be concerned about. And 15 times 16 is 240. X to the fourth. Say 20 times 8, 160. X to the third. 15 times 4, 60. X squared. Interesting numbers. And this is 12. X plus 1. Does that match? It does. Letter A again. So we just had, what did we use? 5, 6, 7, and 4. So your problems might have 3s on them, might have 8s on. No, I don't think I went over 7. I think you'll either get 4, 5, 6, or 7. And I think we did them all the coefficients. So you should be okay. It'll probably make a liar out of me, but I don't think it'll get any higher than 7. I'm just going to tape mine up so it doesn't completely fall apart. I'm done with 24. Couple more. Starting our factoring game. So we'll do these 2 today, and then the next 8 will, on this page is what I won't be here for with y'all tomorrow. So look on the videos, or we can talk about it Friday, you know, on your results for 27 through 34 for Thursday. Now, if you notice, these first 4 all have 4 terms. So when you see 4 terms, you should know the pattern. Grouping, remember? So thankfully, the first 4 you'll have on your semester test in factoring will be grouping. That's when you see them as 2 binomials, and then take out the greatest common factor, take out the greatest common factor, and finally take out the greatest common factor. All the while asking yourself, do they have anything in common, right? So if we look for if they have anything in common, these 3 have an N, but this one doesn't, so that's not in common. These 3 have a 7, but this one doesn't, so that's not in common. So this one doesn't use, so all we have left is to take out a greatest common factor from these 2. So you see 49 and 28 have a 7 and an N squared, because you want the smaller of the 2 powers, and that'll leave you a 7N plus 4. How are you at dividing out a greatest common factor? Super. I hope. Okay, when you have 2 negatives, that means you usually take out a negative. And what you want to take out is usually, so like these guys match. So I see 42 divided by 7 is 6. So if I take out a negative 6, will that give me a match? And yep, 7N plus 4. So that's another way to find the greatest common factor. Once you get the first, shell there, then you might group there. Then you might want to aim for that in your second one. And if it's not possible, maybe it's not factorable. So I think, I don't want to say it looks like they all factor. So now on their answers, they write this 7N plus 4 last. I like to write it first because it's like I'm taking out this greatest common factor of a 7N plus 4. Then I write what's left. And I always ask myself, can I factor that again? These are not perfect squares. So I am done. Always ask yourself. Always ask. Sure you don't ask, you'll miss something. So you notice how their order's different on their answer? Be ready for that. So I really like to pull out my greatest common factor first, and then I like to see what's left over. That's where this comes from. But potato, right? Comment on grouping? This is, let me see, this is 6.4, right? Factoring polynomials. So if you haven't tackled that sweet thing, be ready. At least they're not all scrambled up. Okay, squiggle, they have nothing in common yet. So I look at the first two, 3b squared. I'm making up things. There we go. B plus 4. B. 3 divided by 3 is 1, and b cubed divided by b squared is b. Then 12 divided by 3 is 4, and then b squared divided by b squared cancels. So that's why it ends up being that. Now you look in here, there's no numbers in common, but you remember the negative story. This is one time they want you to write a -1 outside of a parenthesis, because you're going to use it, okay, as one of the binomial terms of your factor. So this, I'm so glad this example was on the practice test. So pull out the b plus 4. And if you're saying there's nothing there, there is something there. Even if there was a positive, there's still a plus 1 you can pull out and have as the term of this binomial. And if that 3 wasn't there, I could factor again. But the 3 is not a perfect square. Therefore, I am done. I was looking for factoring patterns. That's almost the difference of squares, but it's not. Let me see. This is letter A. Letter A, letter A. And that's my conversation done with you. I will let you enjoy conversation with each other and work on homework.